we are pointing the head dot next. Basically, the first dot next is the second. The second one is pointing towards. Hello everyone, welcome to Intellipaat's YouTube channel. This is the part 2 of the Python data structures series. And in this session, we will discuss linked list in Python. Let's take a look at the agenda for this session. So first of all, we are going to start with the basic introduction to linked lists in Python. And after that, we are going to take a look at various types of linked list. Moving further, we will perform the CRUD operations on linked list, and to sum up this session, I'm going to show you how you can implement circular and doubly linked list in Python. So I hope the agenda is clear to you, and without any further ado, let's begin. Before we begin, don't forget to subscribe and press the bell icon to get latest updates from Intellipaat. So what exactly is a linked list? A linked list is nothing but a sequence of nodes that are linked to each other. The linking is done by a parameter that is going to point towards the next node in the linked list. These nodes will typically have two parameters. One will contain the data and the other will point to the next node. The head node will determine the starting of the node and the last node will point to null. Or depending upon the type of the linked list, the last node will point to the other nodes, which brings us to the types of linked lists. So let's take a look at the various types of linked lists that we have. So there are mainly three types of linked lists that we can categorize. One is the singly linked list, then we have the doubly linked list and the circular linked list. A singly linked list will have the last node which will point to null. So we have a head, we have all these nodes which will have data and the next pointer which is going to point to the next node in the linked list, and the last node basically is going to point towards none. So that is how we determine a singly linked list. Moving further, a doubly linked list, or in a doubly linked list, there is an additional node parameter which point towards the previous node as well. So instead of just two parameters, we have three over here. One is the data, one is the next pointer, and the other one is the previous pointer, or the previous parameter of the head node is going to point towards null. And for the last node inside a doubly linked list, we have the next which is going to point towards null and the previous which is going to point towards the second last node of the linked list. After this, we have a circular linked list. So in a circular linked list, the last node of the linked list will always point to the first node or the head node of the linked list. So whenever we reach the last node of the list in a circular linked list, the last node next is going to point towards the head of the linked list. So that is how we determine these three linked lists, which is a singly linked list, doubly and circular linked list. Now that we have a brief idea about what exactly are linked lists, and we have also discussed their types, let's quickly go over the examples which we are going to show you in this session. So we are going to perform a few operations on linked list, which is basically how you create a linked list. Then we are going to tell you how you can insert new elements inside the linked list, which will be like if you wanted to insert a element or a node at the beginning or at the end or in the middle somewhere. Then we are going to show you how you can delete the elements from the linked list as well. And last but not least, we are going to show you the searching and sorting operations inside a linked list. So let's quickly go over to the notebook and we are going to start with our examples for linked list using Python. So first of all, like I've told you in the earlier sessions also, the primary operations for any data structures include creating, inserting elements and deleting. After that, whatever operations that you have inside any of the data structures that are built on top of these three. So first of all, we are going to start with how we can create a linked list using Python. So it is quite an advantage if you already know classes and objects, but if you don't know classes and objects, there'll be a link in the I button. You can follow that link over there, learn about classes and objects, and come back to this session again to understand this in a better way. Now, starting on our session, first of all, to create a linked list, we have to have a node, and then there'll be a linked list which will have all the information about the head, tail, etc. So we are creating a class node over here, which will have two parameters, the basic parameters, the data or the node. So whatever data is stored in that node, and we'll have a next pointer, which is going to point towards the next of or the next node inside the linked list. So this is one class, and the other class which is going to create our linked list, we have the head parameter over here, which will determine the starting of the linked list. So this is how you create the classes for linked list anyway. And after this, the most important part is adding the elements inside a linked list. Now to add the elements inside any linked list which we have created over here, what we have to do is we have created a function which is going to take in the value, the data parameter from over here, and it is going to create a node for that linked list. Now we have also given some expressions over here. What this means is if the head or self of head, then the temporary variable what we have is going to be the head of the linked list. And while we are traversing the list, if it is not none, it is going to go until the end wherever we are adding the nodes over here. The each temporary or whatever variable that we have over here, it is going to become the next of the current node, and we are incrementing the value again. For the next node is going to become the new, and then so on. So first of all, if we are adding just one node, it will be the head node. Otherwise, if it is not the head node, it is going to keep going on towards the next node and add the elements over there. So this is how we have created the function to add nodes inside our list or a linked list. So no errors here. Now after this, we have to provide a function which will print the list as well. So we have created the linked list. We have created a function that is going to add new nodes to the linked list. Now we will create, or we have created a function over here which is going to print the elements or the nodes from the linked list. So here we have determined a parameter called first, which is going to be the first element inside the linked list. And after this, we have assigned the first head parameter. Basically, we are considering this as the starting point of the linked list, and we're going to traverse the linked list over here, and we are going to print the data for each of these values and then go to the next node using this statement. So if you have any questions, guys, you can mention them in the comment section below and we'll be happy to help you out. So now what we have done is we have created the linked list. We have added two functions over here which is going to add new elements or new nodes inside the linked list, and we have a function which is going to print the linked list for us. So this is the first look at how you can create a linked list using Python only by using these classes and objects. So now what we are doing is we are creating an object using our class over here and use this object to add new values. We are adding 20, 30 and 50. So let's add a few more. And after this, we are using the same object to print the list over here. Now when I run this code, this is basically the nodes or the data in each node of the linked list that I have just created. So this is how easily we can create a linked list in Python, guys. You don't have to do anything. You just have to assign a class for your nodes, and then you have to assign a class for your linked list. And then again, you have to make sure that all these parameters are there, like data. There has to be a next pointer pointing towards the next node, and there has to be a head parameter which will determine the starting point of the linked list. So I think this is clear to you guys. If you have still any questions, you can mention them in the comment section below, guys. Also, this might be a little bit tricky for people who are not aware of classes and objects. So I would suggest you to check out that session that we have created on classes and objects, so that you'll be able to understand this better if you have a prior knowledge of how classes and objects work, how you can create objects to access the parameters on the classes. So what we have done right now is create a linked list, and we have added the elements in the linked list. So we have already created and added the elements. Now we'll take a look at how we can insert elements inside a linked list, and these insertions can happen at the beginning of the linked list. Insertions can happen at the end of the linked list, or we can have a custom value where we will provide the previous node, or the consecutive nodes where we'll want to provide our new node or insert the new. So we have created the functions for each of them. So since we are adding this in the beginning of the linked list, what is going to happen is the new node next pointer is basically going to point towards the self dot head, which is the current head of the linked list, and it will become the second element of the linked list, and that is what we have done. And self dot head will become the new node. So there are three steps over here. We are creating a new node. We are making sure the new node is pointing towards the current head of the linked list, and after this we are assigning the head parameter to our new node. So whenever we add this, or whenever we use this function, whatever value we are providing over here is going to be added in the first node or the head node of any linked list, or the linked list that we have created using the object. After this, we have a function which is going to insert the value at the end of the linked list. Now for this, we have to follow additional 2 or 3 steps. First of all, we create the new node, and then what we are going to do is we are going to traverse toward the last node, and for that we are using a while loop. So as soon as we reach the last node, what will happen is the last node next pointer is going to point towards the new node that we have created. So that is how we have added the new node at the end of the linked list. And after this, we have another function which is going to insert the node after a given node. So here we'll have an additional parameter. Basically, we have data that has to be added inside the node, and then we have the x parameter over here, which is going to be the data at the node after which we want to insert our new node. So whatever we have done here is we have assigned these values, and there is a temporary variable that we are going to use to traverse towards that node. Now once we find that node, obviously after assigning the new node, we are using the while loop here. We are traversing towards that node, and as soon as that node's data becomes x, or whatever value that we have for the previous node, it is going to make the next pointer for the new node the current next, and then it is going to point towards the new node, the existing one. So basically we just add a new node in between those two nodes which we have traversed toward. So this is a very simple example, guys. And just after this, let's discuss deleting the new node, and we'll put together all these functions and understand how we are doing this. Alright, so I'll just quickly run these functions. So we have already created a list over here which has all these values, and now let's just discuss deleting the values inside a linked list. For this, what we have to do is traverse toward or find that node which we have to delete, and as soon as the data becomes that, we are going to point the current pointer towards the next. So let's say if I want to delete x node, and before that there is a y node, and x is pointing towards z node, what I'm going to do is find out x, and y dot next should be equal to z. So we are just skipping through the one, and it should be deleted. That is how we have created the function for deleting a element or deleting a node from a linked list. So let's take a look at how we can create a function to delete any element or delete a node from a linked list. So what we have to do is we have created a function over here which takes in the parameter value. Now what we have to do is traverse towards that particular value which we have to find out. And after that, once we find out that particular node, we are going to provide values like, let's say we are finding out the node x. Before that there is a node y, and after that there is a node called z. So what we'll do is find out where x is, and after that the previous node which is pointing towards x, we will point it towards z, so that it's basically going to point towards the next one and delete the current one that we are trying to delete. So that's how it should take place, and that's what we have done over here. The previous is going to be is equal to temp, and temporary will become temporary dot next, and after that we have assigned the previous dot next is equal to temporary dot next, which is basically how x is going to be missing and y dot next is going to point towards z. After this, we have a simple function to search through a linked list as well. So this is basically going to have another parameter. This is x, what we have to find out inside linked list. Then again, we are traversing through the end of the list using the while loop over here, and if the data is equal to x, we'll just print it is found, and if it is not found, we are not doing that. Else we'll just we can add another else statement over here. Else we'll just print not found. This is basically the increment for the current variable over here, so that it reaches the end of the list. And after this, we have another function which we have created to sort a linked list. Now this can follow a simple approach, where what we have done is we have created a temporary list where we are getting the values from the nodes or the data and then storing it in a completely different list. After that, we are sorting that list, and the resultant list, whatever we're getting after that, we are again putting it inside a new linked list, which is basically the sorted linked list of whatever we already have. So this is what we have done. We have created the temporary variable, and then there is this is the empty list where we'll store our data points from the linked list, and we are traversing towards the end and appending all the values from the linked list, and using these values we're just sorting it out in ascending order. After this, we have created a new list or a new linked list, and we are adding these values inside the new linked list using the add function that we had created before, and after that it will just print the linked list for us. So now that we have created, or we have understood how we have created all these functions for sorting, searching, deleting inserting in the middle, inserting in the end, or just inserting in the beginning. Let's just put them all together and understand how our linked list is working over here. So we have added all these functions inside this program or the code. Now what we'll do is, let's just create a linked list. All right, just let me just run that code once. So no errors, we're facing no errors, so that we can go ahead with this. Now we have created an object, or we have created a linked list. Now using this object, we'll just add a few values. So we'll add the values in such a way we are able to understand all these functions that we have created. So let's just add 4 values for now. So since we want to add something in the beginning, we'll start from 20, 30, and this will be, let's say, 50, because we wanted to add something in the middle as well. We'll keep this as 60, and after this we'll add something after the end of the list as well. Now we'll use the insert method to insert in 10 in the beginning. We'll use insert mid. Now let's take a look at how we are inserting in the middle now. So we have to give the data and the node where we want to basically insert the value after. So we want to add 40 after 30. So we have to insert at the end, and we'll insert 70 because we already have 60 over here. Now let's just take a look at the list and see if we are able to get all these values. So we have 10, 20, 30, 40 we have added using the insert mid method, and then we have 50, 60 and 70. Now let's say if I wanted to delete something. All right, so I'll use the delete method that we have created, and now we'll delete 70, for example. After this, let's print our list again. We'll comment this so that we'll only get the resultant one, and you can see we have deleted the last element from the linked list. Now after this, let's just take a look at if we can search through the linked list or not. So let's say we wanted to search. Okay, we'll comment this one. Now we want to search if 60 is present or not. So let's see what the output is. It's saying it's found. And if I, let's say, try to find out if 70 is present, it's not giving us any. All right, so we haven't added the else statement over here, which we'll do now. It's going to print not found, and let's see if it is going to show us any. Okay, all right, so for all the values it is basically showing us not found because we are in a while loop. So we can make the scope of this if else statement outside the loop, and it will just show it only once. And now that I've shown you searching, and let's just replace these values and create a list that will have, for example, these values. It's easier to understand how sorting is working over here. Now let's just print this one. So our list right now is 30, 20, 20, 50, and then we have 70 and 60. So these are the nodes or the data points inside each node of the linked list. Now I want to sort this into ascending order. So let's just see what the output is, and we'll comment out this one for now. So if you can see, the output is 10, 20, 30, 50, 60 and 70. So we are able to sort the linked list using our sort method that we have created with all these values that were not in ascending order, but the result is in ascending order. But the only difference is this is an entirely new list that we have created in this particular method. So this is the new list that we have created. This is not the old linked list that we are sorting. So this is something that we'll discuss later on in other sessions when we are discussing searching and sorting in probably the part 5 of this data structure series. So don't worry guys, and stay tuned for more such sessions. And now that we're done with the basic operations, the creating, updating, deleting, we have also sorted and searched for elements inside the linked list using Python. Let's also take a look at how we can implement circular linked list and doubly linked list using Python. So the basic idea about circular linked list, we don't have to do anything. We just have to modify one thing, which is the last node of our list or the linked list is going to point towards the head of the linked list. So we are basically following the same approach. We have created a class node, we have created a list, and there is a method to print the list over here. Also, there is just one modification here. When we are printing out, we have added this expression where if first.next is equal to self.head, which is the head node of the linked list, we are breaking the loop over here. because we don't want to run it in circles, it will create a loop because it's pointing towards head, and then the head will point towards the second one, third one, and then again it will come back like that. So we have not created an add method over here. We will just create it on our own. So we are using the object over here for our class list. Using that object, we have created the head, which is the node 5, and we have created a second node and a third node. After creating these nodes or adding the values inside a node, what we're doing is we're using these next parameters that we have pointing towards the next one, which is the second one. Head is basically pointing towards the second one. The second is pointing towards the third one. Since the third node or the third is the last node inside our linked list, what we are doing is we are pointing third towards the head, and that is how we have created our circular linked list. So these are the values. Now just to check if it really works, we'll just print third dot next dot data. So it should basically show us that it is 5 because 5 is the head node and third is pointing towards 5. So this brings us to the last part of the session where we will implement the doubly linked list. So here there's a slight modification. Unlike circular and linear singly linked lists, in a doubly linked list we will have another parameter inside the node which is going to point towards the previous node. Alright, so we have created next. After that we have created the previous parameter as well. And after this the approach will be same. We're going to create a class for our linked list. Then we have created a function to print the linked list as well. Here we are not using any modifications because we would just want to print our linked list from starting to the end. Now we have created the object for our list. The next objective is basically making a head node. We have created that, a second node and a third node. Now we'll have to provide the next pointers for each of them and the previous pointers as well. So we are pointing the head dot next. Basically the first dot next is the second one is pointing towards third. Since third is the last node in the linked list, it is pointing towards none. Now coming back to the previous pointer, the head node is going to point towards null, which is none, and the second one is pointing towards the head, third one is pointing towards second. Now when I print my linked list over here, we have all these values. Just to get a check, let's just check if object dot head dot previous, where it's actually pointing, it's none. And now let's just check for the next, pointing towards, all right, it's pointing towards the second one. Let's just check for the second dot next. It should be pointing towards the third one, which is correct, and the third dot next should be pointing towards null. All right, so we don't have any data for none type, so we'll just print this, and it's pointing towards none. And now that we have come to the end of the session, if you have any questions, you can mention them in the comment section below. Also, don't forget to check out the part 1 of the series and learn about Python arrays and array implementation using Python array module and NumPy arrays. And we'll be happy to help you in your journey towards learning Python data structures. Thank you and stay tuned for the next part of this series. Now that we are done with the session, don't forget to subscribe and press the bell icon to get the latest updates on Intellipaat.
Just a quick info guys, if you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.